Hello again, boys and girls. So now we're going on to part B of polygons. And so this section, boys and girls, is we've talked about the objective. So now we want to get into all the vocabulary that we're going to deal with this particular lesson. So the vocabulary is as follows. We're going to have to know a polygon, quadrilaterals, square, parallelogram, rectangle, rhombus, vertex, and trapezoid. So we have polygon, quadrilaterals, square, rectangle, rhombus, vertex, and trapezoid. And I'm going to put something in blue here, boys and girls. Special fella there. So we had trapezoid, but you're going to have to know what an isosceles triangle is. Okay? So to continue with our vocabulary, right? Once again, this is part B. We're going to first talk about what is a polygon, okay? Because everything is predicated, everything is built along what a polygon is all about. So a polygon is a closed figure that has very specific attributes. A polygon is a closed figure that has very specific attributes. So what are those attributes? What are those characteristics? Well, as you see, every side of a polygon is straight. Every side of a polygon is straight. What else? Every polygon, they have corners wherever two sides meet. Okay? Polygons have corners wherever two sides meet. So just like in our previous lesson on last week, when you have an angle that has two lines or two rays connected by that corner or that specific dot that I'm going to put here, that specific corner where two sides meet from last week, we should know that that is your vertex. Okay? So this is what we have to know starting out with this lesson. What is a polygon? So let's take a look at some examples. Here on the left side we have polygons, and they are closed figures. But then on the right side, boys and girls, we have something that are unique in their own right, but they're not polygons. Why? Because they don't fit all the characteristics or attributes up here when they say, because these particular figures have some type of openness, or all the lines are not straight. So let's look at these closed figures. Now they all look truly different, but they meet they meet the criteria of what a polygon is all about. Now, does this figure have all straight lines? Well, I'm not the best artist, but yes, it does. Does it have corners? Yeah, it has the corners. Okay, wherever two sides meet. So that's a polygon. This object here truly does not look like this one, but does it have straight lines? Yes. Do they have the corners? All types of corners. That too meets the characteristic of a polygon. this figure here. Does it have all straight lines? Yes. Does it have corners or vertices or vertex? Yes, it does. All these are vertexes. Polygon, closed figure. Right here, all straight lines. They have the corners with the vertexes. It's a closed figure. Polygon. This figure here. Does it have straight lines? Yes. Does it have corners where two sides meet? Here's the corner where two sides meet, 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 polygon. And finally, this object here. Does it have all straight lines? Yes. Okay. Is the figure closed? Yes. Does it have corners? Yes. All these corners. Where the vertex allows two line segments to meet. A lot of them there, but it meets the criteria. That too would be considered a polygon. So all 6 of those figures are polygons. Now, let's look at the right side. Okay, if it's a polygon, it's supposed to have straight lines, no openness in all corners. Well, look at this first object here. What's the first thing that you notice? Yeah, I see straight lines and corners, yes. But this area here, it's open. So right then, by definition, it's not a polygon. What about this figure here? It has straight line and vertexes, true, but we have an opening here. So because that line does not close that object, it's not a polygon. This figure over here. Yes, it has straight lines. Yes, it has a vertex, but it's open here, and it's open there. So therefore, that's not a polygon then, because the figure is not closed. Look at this figure here. Right off, you can say that the spiral is in a circular motion. So by definition, we already know it's not straight. So we know this object here is not a polygon. But look at this object here. It has straight lines. It has vertexes. But what's the one problem? It has an openness right here. So because it's open and it's not a closed figure, it's not a polygon. Here, this check mark, so to speak, it's not closed up here, therefore, it's not a polygon, even though we know it has straight lines and vertex, but the figure is not closed. Right here, the X again, not closed here, not closed there, not closed, not closed, even though it has straight lines and vertexes, but it's an open figure. This final figure here doesn't have any straight lines, but it's closed, but doesn't have any vertexes. It's an oval. So right there, if it doesn't have any straight lines, it's not a polygon. This object here that looks like it has kind of like 3 ice cream cones, so to speak. Guess I'm getting a little hungry, boys. I always come there thinking of some type of food. Now, it has vertexes. Yes, it has straight lines, but look at those cone shapes. That's what curve it. So it's not straight. It's not a straight line. So therefore, it's not a polygon. So in closing in part B, boys and girls, you see on the left side, when you go back over this tape, everything on the left side by definition is a polygon because it's a closed figure. It has straight lines. and has corners or a vertex, but on the right side, boys and girls, there's all three of those attributes or characteristics: closed figure, straight lines, and size closed. Something is missing on that right side, meaning that therefore it's not a polygon. Okay? And boys and girls, and that will be the conclusion for part B.